balancing in acidic solution. A while ago, we had just finished one example. Now we proceed to another example. Kindly have your eyes in the whiteboard. Say number 2 example. We have aluminum plus hypochlorite is equal to aluminum 3 plus chloride. Okay, let's start now. Okay. Oh my gosh, sorry. Let's get started. Or let's begin. Our timer starts now. Okay. Oh my gosh, there's a reflection. Oh, it's so garish. I cannot really be clearly seen in the screen. So the light reflection is so garish. Garish is so bright. Get the point? So I need to energize and activate my brain cells by drinking first this low-fat milk. Mm. Oh, I love it. Okay. So, first step, determination of oxidation state and oxidation number. Hello, I'm coming back for the continuation of this redox balancing in acidic solution. Okay, determining first the oxidation states and numbers changes so that we can be able to determine reduction and oxidation. Okay, here. So pair the aluminum here and the hypochlorite and the chloride here. So, aluminum, free state, so 0 oxidation number. So aluminum to aluminum 3 plus. So it is less in the reactant, the aluminum. So that's gonna be loses electrons. So it's gonna be oxidation or increasing oxidation number. Okay. Now take a look with your hypochlorite and chloride. Since you do know yet the oxidation number of chlorine, then we need to solve for that. Let's use, sorry guys. Okay, are you still there? Yes, thank you. My viewers, my avid viewers all over the world. Thank you so much for staying in my channel for this live discussion of redox balancing in acidic solution. Okay, now since we don't know yet the oxidation number of chlorine, we have to determine that. So, negative 2 oxygen. So, let X as the oxidation number of chlorine. So that it will become negative 1 as our net charge in the whole polyatomic and ion hypochlorite. So, X plus negative 2 is equals to negative 1. What number you will put there in order it will become negative 1? Okay, it's gonna be 1 only. In this case, you are doing the trial and error method because we are dealing with a very least or a very small numbers. Okay, things like that. So from positive to negative 1, it is really increased. So this is gain of electrons. So this is reduction. Okay, things like that. Or, see, decreases the oxidation number. So from positive 1 to negative 1. So decreases meaning reduce or reduction also. Okay? Things like so half reaction. So balance first the atoms, visual inspection. Yup. All are balanced except there's oxygen. Okay. First takeaway. The moment you will see oxygen, it could really signals you that there's something wrong with the products. That it's not really balanced with the reactants. It's not really tantamount with the reactant. Okay, because it's not compatible. If you have oxygen in the reactant, there must also an oxygen molecule or atoms in the product. But it's nothing here, right? Okay, just leave that there. Go to the half reaction. So don't worry for that because as we go along the process, we can determine the oxygen in the product. Half, okay, oxidation reaction. Wow, so many actions. Okay, so let's designate now nomenclature so that we will not too much consuming time in saying the one terminology. So oxidation O, reduction R. Okay, things like that. So oxidation is very clear. Aluminum 2, aluminum 3 plus. Then you have to add electrons in the product because this is losing electrons or oxidation. So plus 3 electrons. Okay, why 3 electrons? Because that is the only electrons you have to add with the 3. It will become 0. Okay, so this does not need algebraic expression to think, right? Things like that. And then aluminum is in a free state, that is also 0, so charges are equal. So 0 is equal to 0. How about your atoms? So one atom of aluminum in the reactant and one atom of aluminum in the product, so it's equal also. Now we go to reduction. Okay, so hypochlorite, okay, negative, okay, to chloride negative. So you need to add electrons in the beside hypochlorite, so plus X. This is the time you will use algebraic equation to get the number of electrons to be added with hypochlorite. Because if we depend in our original redox equation, we will say for chlorine, see, from positive 1 to negative 1. Okay, it drops only to a matter of 1, like that, and you will put, say, here 1 electron. Sometimes it always be wrong based on your experience, so don't rely on that. So go to the algebraic expression. Okay, now since you have hypochlorite, then you need to add water to the right to compensate the atoms of oxygen. Okay, to be in the equilibrium. So things like that. So plus. Okay, water alone. Why water alone? Because oxygen is 1 here, atom. Oxygen is 1 also here. Alangan mag 2 moles of water. So it is not logical. Right? It is the point. So once you add water, you also add H plus on the other side. So this is 2 times 1. So that's 2H plus. Okay. Things like that. Now compute for the charges and balance the atoms. Atoms balance clearly, see? Hydrogen 2 atoms. Okay, oxygen 1 atom. Chlorine also is 1 atom. So the atoms, no issues. Right? Okay, and then the charges will be an issue. So we need to put an unknown X that would be our unknown electrons for our algebraic expression. So balance charge. So positive times 2, 2. Okay. Negative 1 times 1, negative 1. Okay. Plus X is equal to negative 1 times 1, negative 1. Plus 0 is the oxidation state of water. 0 times 1, that is 0. Okay, so 2 plus negative 1, positive 1, because 2 is greater than negative 1. Okay, plus X is equal to negative 1. So X is equal to negative 1, transpose 1 here in the right, it will become negative 1. So X is equal to negative 2 would mean 2 electrons. The negative sign here would mean that it is an electron with negative sign. Okay, that's the purpose only in here. Okay, things like that. So, erase the X and change with 2 electrons. So, 2 electrons. It will now become 2H plus plus hypochlorite plus 2 electrons is equal to chloride plus 1 mole of water. Things like that. Okay, add the 2 half reaction, this 1 and this 1. What you will identify or what you will notice is that the number of electrons are not the same. They are not lucky here. So what is the number we'll be able to multiply to compensate that it will be equal somewhere along the way. So in this case, the technique in this, guys, is you have to start from the least number going to up. You will never start with a big number. Obviously, even in math, just the procedure. That's the procedure, right? So start with 1. 3 times 1, 2 times 2, it will not be equal to 2. 3 times 2, 6. 2 times 2, 4. It's not equal also. So you need to multiply this with 2 and the other one also will multiply this 3. That's the technique. Okay? Because it's not really equal. So, put parenthesis the whole oxidation times, okay, 2. Okay, and the reduction also, you need to multiply that with 3 so that it will become 6 electrons also in the oxidation, so 3. So, now we have now our reactions here. Eyes on the board, please. Okay, so it will now become, nakakaloka, 2 aluminum. By the way, this is saying 2 moles of aluminum and 2 atoms of aluminum. This is the case where the atoms and the moles will be equal. Okay, in what situation? When there is no subscript. The definition of one atom and definition of one mole will be equal in chemical reaction. But the definition statement and concept are not the same. Because small is the unit of the amount of substance, and atom, okay, is the smallest particle in a nucleus. You get the point? Things like that. No, mga palangga. Uy, I don't have intensifier. Today, or at this moment, I don't have the magnifying glass. Okay. Magnifying glass. Nakakaloka. Because the point, I don't have the magnifying sound because I don't have now the microphone. I charge it, okay? So 2 aluminum, okay, then equal to 2 aluminum, 3 plus 6 electrons. And here, 3 is gonna be 6, so 2H plus times 3, so 6H plus. Okay, plus hypochlorite, okay, plus 2 electrons times 3, 6 electrons is equal to 3 times chloride is equal to 3 moles of chloride, okay, plus 3 moles of water, okay, things like that. Now, visual inspection, we have still here the 6 electrons here, add the 2, then cancel the 2 electrons. Then review 2 aluminum, okay, 2 aluminum, okay, 6 electrons, 6H, okay, 6H, then 3 times ClO, this is 3 ClO, and then plus 6 electrons, okay, perfect, okay, okay, so, like that. So what will be left here, so this one, 2 aluminum, okay, the point, plus 6H plus 3 hypochlorite. When you said hypo, it's always hypochlorite, it's not hypochlorite. Okay? Equal to 2 aluminum, 3 plus. Okay, plus 3 chloride, plus 3 moles of water. Okay, now balance the chemical in terms of atoms and charges. Aluminum, 2 atoms, balance. Hydrogen, 6, 2 times 3, 6 balance. Chlorine, 3 balance. Oxygen, 3 balance. So atoms are perfectly balanced. How about the charges? Okay. Aluminum free state oxidation number is 0. 0 times 2, 0. Okay. Positive 1, H plus times 66. Then negative 1 for hypochlorite times 3, negative 3, right? Is equal to 3 times 2 of aluminum is gonna 6. Negative 1 times 3 is negative 3. Then for water, the oxidation state is 0 for a compound, the net charge. So 0. 0 times 0. Okay. 6 minus 3 is 3 equal to 3 is the perfect. The charges also are balanced. So therefore, we conclude that our net redox equation is this. 2 moles of aluminum plus 6 moles of hydrogen plus 3 moles of hypochlorite is equal to 2 moles of aluminum 3 plus or 3 positive plus 3 chloride plus 3 moles of water. Any questions so far? For example number 2, imbalancing redox equation in acidic solution. Now, I will give you an assignment in order for you to solve by your own so that we can measure our learning outcome and our comprehension level with regards to this topic. Okay, so your assignment class would be this. Okay, I'll give you the assignment. Then tomorrow we will solve this. Okay, you have this one, permanganate. Kakaluka. Yes, permanganate plus iron is equal to ferric 3 plus Mn2 plus. So this is your assignment. Okay, now I'll give you a little bit of explanation the difference between manganate and permanganate. Okay, permanganate has -1 charge. Manganate have -2 charge. That's the only difference. You get the point? There's no Mn2O4, huh? It's always MnO4, whether permanganate or manganate. But in this case, this is permanganate. Meaning to say, in the manganate level of understanding, okay, special case, you know, the lesser will be the pair. The higher charge will be the without pair. So permanganate, -1 charge. Manganate, -2 charge. Things like that. It looks like the reverse, right? Because normally we will start from the list if there's no prefix. You got the point? Just like saying oxide, superoxide, peroxide. Their oxidation state changes the more we put on prefix to match. So prefix meaning super, per. And our root word is oxide. That's what we mean by prefix. Here also, permanganate, the prefix is per. The root word is manganate. Here, it's the reverse story of the oxides and other compounds. That's why I said this is a special case because the permanganate, okay, has negative. Things like that. The other one is 2. So 2, okay, the other one is 2 here. Okay, it's correct because -2, no? Yeah, it's because -2, yes, it's reverse talaga siya. Okay, that's because I say manganate. Manganate is -2. And then permanganate, sorry ha, let's explain this, scrutinizing word for word. Okay, so -1. So -1 is larger than -2. This is permanganate. You add prefix. Right? Supposedly, it could be manganate have -1 because it's higher because there's no prefix. But in this manganate thing, permanganate thing is special with the other, polyatomic and ion because normally, the higher the oxidation state number, you have to put prefix. For example, carbon tetrachloride. Okay. Oxygen tetroxide. Okay. Oxygen pentoxide. Things like that, O5. Like the more it will add too much prefix, the more your oxidation number will increase. You get the point? Things like that, okay? Because oxidation number, oxidation state are not really equal to charge. Okay, that is only good if you don't have subscript. The charge will be equal your oxidation state. You get the point? So, again, oxidation state and oxidation number is not equal of charge. Okay? So, that's why you observe that sometimes because there are situations that the oxidation state and oxidation number will be equal only to the charge. Because the main reason, it's not in the compound, it's not blended in the compound, or there's no subscript. You got the point? Things like that. Okay, for example, oxygen, -2. The same time also the charge is -2. So, both the charge and the oxidation state will be the same. If I will say oxygen and oxygen gas, okay, how can we say that? Okay, things like that. So, there's now subscript. So, you can never say automatically that's equal all throughout. Ganon. So, it's your assignment. I hope you like it. Any questions for that? Okay, any comment? You can have comment down below in the comment section. And you can share also this REDOX balancing and acidic solution. Now, I'll go back to you guys. I'll be coming back later for the redox balancing in basic solution. Okay, bye-bye. Guys, I will tell you that basic solution is a little difficult compared to acidic.